Okay, we're going to look at an application interest problem of three equations, three unknowns. Here it is. Jose invests in three accounts. One pays 5% interest, one pays 7, and one pays 3.5%. He invested a total of $30,000, and he earns a total interest of $1,475 in 1 year. That's his total interest in 1 year. And one more thing, he invests twice as much in the 7% account than he has in the 5% account. So let's look at this. What do we need to know here? There's three. Oh, you actually need a question first. So the question is, how much does he invest in each account? You might be sort of used to that question, being in an algebra class. You need to know that he's investing in three accounts, so 5%, 7%, and 3.5%. Also that he has a total of investment of $30,000 and a total interest of $1,475, and that's the total interest in 1 year. And it's simple interest. And also there's this relationship, twice as much in the 7% account as the 5% account. We're going to come back to that one. Let's just take this information, and so I'm going to make a table. The first thing I want to do is set up some variables, and these are my unknowns, and this is the amount invested in each account, and I'm going to call this X, Y, Z. And let's see if I remember, it was a 5% account, and then there was an account that paid 7%, and then there was an account that paid 3.5%. Okay, so with all these interest problems, this is the basis of my table because I'm solving for X, Y, and Z, and I know that. But let me for a moment back up, and we know that interest, simple interest, is principal times rate times time. Total interest, that is $1,475, and that's a little bit harder to think about how I add up the total interest. So that's what we're going to be doing basically on the last page that I was just showing you, which was starting to make that table. This, by the way, the time for this is 1 year. So in fact, I can actually just erase this for time because I'm just multiplying by 1 each time. So really it's just, I'm doing the principal times the rate because it's for 1 year. So let me go back and do that. So here is basically my principal, the amount invested. I'm going to write my interest or my rate in decimal form. Well, I know the interest is principal times the rate, so this is, I could write it as x 0.05, but that just looks silly because, I don't know, with a coefficient I usually put it in front. So being a math teacher, I'm just inclined to put the number out in front, the coefficient in front. Oops, that's not x, that's y. And then we have 0.035z. And down at the very bottom, I'm going to write total. So my total, well, it's x plus y plus z. This is the total principal, which was 30,000. My interest, I can't just add up interest. When you think about it, if you could just add up interest, like I get this from this account and this from this account, so now I have, let's see, like 15.5%. Like that would be wonderful because I'd just put my money in a million different accounts and I'd get 1,000,000% interest, right? Okay, no, doesn't really work like that. There is some, average interest rate, but we aren't actually interested in, we don't know it, so I'm not even going to add those up and worry about that. Or what we do know is our total interest. Our total interest was $1,475, and that's equal to 0.05 times x plus 0.07 times y plus 0.035 z. X plus y plus z is 30,000, and I have 0.05x plus 0.07y plus 0.35z equals 1,475. So let me write those two equations down. Okay, so I've written them down, but what's going on here is I have three variables or three unknowns, and I only have two equations. And if I want to solve this, then just like you can't have one equation with two variables like x plus y equals 2, and then just have one equation. If you have two variables, you need two equations. Well, if you have three variables, you need three equations. So we're missing one equation here. So let me go back to our original question and try and find it. Okay, so I got all of this stuff up here. 5%, 7%, 3.5%, 30,000 total, the interest in 1 year. But what I didn't get was that he invested twice as much in the 7% account than in the 5% account. So let me go over here. He invested, let me write that down before I forget it. He invested twice as much in 7% as in 5%. Okay, so what we're dealing with is how much he invested in 5% and how much he invested in 7%. And let me just think about this for a moment to think about which one do I want. Do I want x equals 2y or y equals 2x? So let us remind ourselves that x corresponds to the 5% and y corresponds to the 7%, how much he invested in the 7%. All right, now what we want to say is he invested twice as much, 2 times as much in the 7% as in the 5%. Let's say that he invested $8 in the 5%. Obviously it's a lot more than that, but I just want to test it out. Then there would be $16 in the 7%. So that would mean this would be 8, this would be 16. So if x is 8, 2 times 16, oh wait, that doesn't work. But if this is 16, we get 2 times, okay, so twice as much in the 7%, so that y will be a bigger value as in the 5%. It's y equals 2x. All right, so we've got 3 equations and 3 unknowns, and I would like to, we need to basically get 2 equations and 2 unknowns. So the way I'm going to do it here is substitute equation 3 into equations 1 and 2. So for equation 1, instead of y, I'm going to write 2x. So I have x plus 2x plus z equals 30,000. I am going to rewrite that, and I should probably call that equation 4, which will be 3x plus z equals 30,000. Okay, I need to do this again, and I need to substitute equation 3 into equation 2 now. So again, I'll have 0.05x plus 0.07, and instead of y, I'm going to put in 2 times 2x, plus 0.035z equals 1,475. Those are my interest values for the first, second, and third equation. And of course, I want to rewrite this because it's 0.05x plus 0.14x plus 0.035z. And I'll go ahead and rewrite these equations on another page. I'm going to use these two new equations. I'm going to call them equations 4 and 5 to solve for x and z. So here I better label, this is equation 5, and then we have equation 4 here on the left. So here they are, equations 4 and 5. And I have decided, looking at this, to use the addition method. You could use the substitution method, but I've decided to eliminate z. And in order to eliminate z, I'm going to multiply the first multiply equation 4 by negative 0.035. So that way I'll have a negative 0.035, a positive 0.035, and z will cancel out. So when I rewrite equation 4 after multiplying it by negative 0.035, I get the following. Okay, now I want to bring down equation 5, and I am going to add these two equations together. It's the addition method, so I get two of them as opposites and for one variable and add them together. So what I get in the end is negative. It's not negative, but it's positive 0.085x equals 1,475 minus 1,050, which is 425. I divide each side by my coefficient, and I solve for x. And when I get x, I get $5,000. Okay, so he's invested $5,000 in x, 2 times that in y. And z must be 15,000 because the total is 30,000. So I just had these in my head. I go back to my equations. Y equals 2x, x plus y plus z equals 30,000. And I solve for all of them, and I get the 3. But x, y, and z isn't really exactly what we were solving for. We wanted to know what was the 5%, the 7%, how much was in 5%, 7%, and how much was in the 3.5%. So you go back to your table and solve.